Hi everyone. So wave lesson 2, we're going to talk about time period and we're going to talk about frequency, and we're just going to tighten up on our wave terminology before moving on to something else in lesson 3. So this is all really about keywords still, making sure we know what they mean and how to use them. But the keywords of frequency and time period, I guess, include a bit of maths in their kind of definitions. So we'll go into that. Okay, so first up is time period then, and this is the simulation that we had last lesson. The Flipchart physics sheet told you to open this. I'm actually going to slow this down a little. So, oh, that's a bit too much. So we've got this wave that's being produced by this bar that's going up and down. And so our key words then, we've the time period of this is the time it takes for one complete wave to go past. Oh look, it's Mr. Rana. The time it takes for one complete wave to go past. So we could sit here and we could time how long it takes for one wave to go past. So that's the peak, that's the bottom, and there we go. Okay, so we've got peak, trough, and then that's your one wave. If you can't see that, it might be a bit clearer actually if I do it a bit faster. So we've got so starting now and then now. That's one time period. So the time period is the time it takes for one wave to go past, but because of the way that waves work, it's also the time it takes for one particle to do one complete oscillation. So if we start this particle in the rest position, so it goes up, goes back to the rest position, down, and then back to the rest position. That's one oscillation. And so if we could time how long that took, that would be our time period. And if you're the sort of person that likes to make notes in your exercise book, you might want to write down that the time period is the time for one complete oscillation, or the time for one complete wave to go past. If you're not going to do that, that's because you're going to revise from a revision guide probably, and I don't mind if you write it down or not. It's up to you. Depends how you learn. But that's our time period. So I could sit here with a stop clock and I could press start and stop. It's not particularly accurate. You might want to time 10 and then divide by 10, and then you can get a much more accurate answer if you're actually trying to find the time period. But that's what time period means. Frequency then is kind of the reverse of that. The frequency, the definition is completely backwards. With frequency, the frequency is the number of waves that go past in 1 second, or the number of oscillations in 1 second. And so that's completely the other way around to time period, but they are related by this number 1. Time period, remember, is how long it takes for one wave to go past, and frequency is how many waves go past in 1 second. So they're related by this number 1, which we'll remember for something else later on. But in terms of frequency then, I'd start my stopwatch and I'd time 1 second and I'd count how many oscillations we'd got or how many waves had gone past, the same thing. With this, it's going so slowly that I might be able to do that, but I'd need to time maybe 10 seconds, maybe 100 seconds, and then divide to find how many waves actually went past in my 1 second. In your exam, you'll get this equation sheet if you're doing combined science. You'll get a more comprehensive one actually if you're doing separate science. But we can see equation 4 here says period equals 1 over frequency. And that equation then relates our two things. It relates the time period and it relates the frequency with each other with this number 1 look that was appeared in both definitions. So time period is 1 divided by frequency. So if you know the time period, you can work out the frequency. And if you know the frequency, you can work out the time period. We've got these definitions then, and we might be expected to use those definitions to calculate something. So you've got, so you might want to calculate the time period or to calculate the frequency just from the sentences, the definitions that we've got. So if you've got this question, so a girl stands on a boat, feels the boat rise and fall 7 times in 1 minute. To start with, as soon as we read that, actually, we need to get rid of this 1 minute and turn it into 60 seconds to have SI units. Otherwise, we're going to get the answer wrong. So calculate the time period of the water wave. So the time period is how many waves go past in, no, it's not. It's the time it takes, isn't it, for one wave to go past. So if 7 waves go past in 1 minute, we need to find, or 60 seconds, sorry. We need to find the time it takes for one wave to go past. So we can just divide by 7. So we've got 60 over 7, that's the time period of the water wave. There's another way of doing that. I guess you could have a ratio. You could say 7 waves takes 60 seconds. So to get one wave, we can have 60 over 7. This isn't the final answer. I haven't got a calculator. You hopefully have got a calculator. Type it into calculator, press equals and turn it into a decimal. You might need to press that SD button. Turn it into a decimal that's to an appropriate number of significant figures, which is 1 or 2 in this case. And that's measured in seconds. There we go, look. But you might also need to find, you might also be asked to find the frequency. So calculate the frequency of the water wave. So the frequency is how many waves go past in 1 second. So if I've got 7 waves going past in 60 seconds, in 1 second I'll have 7 divided by 60 for my number of waves that past in 1 second, and that's measured in hertz. We could do that with a ratio as well. So we could say that 60 seconds is 7 waves. How many waves do we have in 1 second? Then it'd be 7 over 60. Do whichever way you feel more comfortable with, ratios, or that's kind of just using logic, isn't it? It's up to you. Last thing I'll say though, look, is that these fractions are very similar. And this is where our formula comes in, that time period is 1 divided by frequency. If we get our frequency, I'm just putting this number out here, we can put that into this formula and we would find that the time period is then 60 divided by 7. So actually, once you work one out, you could use the formula to work the second one out. So these two, the time period and the frequency, are linked. They're linked by this number 1. That formula is on the formula sheet, as I've just said. Good luck with the questions on the worksheet.